Today we will derive three equations of motion for uniform acceleration. The first one is velocity time relation, that is v is equal to ut. Next is position time relation, that is s is equal to ut plus half at square, and the last one is velocity position relation, and that is v square minus u square is equal to 2as. Okay, then we will talk about uniform circular motion, the motion of the planets around the sun, the motion of almost electron around the nucleus inside an atom. Then we will talk about centripetal and centrifugal force. One is real, another one is non-real, that is pseudo. And how do those equations, three equations that we learn in the beginning of the chapter, will take different from when the object is thrown up with some initial velocity and when object is falling down. Okay, when the object is falling down only under the action of the gravity, that is also known as the free fall, because there is no other force acting on it. You just release the object from a certain height, then it keeps falling towards the earth with that acceleration small g, which is known as the acceleration due to gravity. So that we call free fall. So we will see how those equation changes, right, for those two different kinds of motion. So let's begin. So to derive these three equations of motion, we will use a graphical method here. So you have drawn a graph. Here is a graph of velocity versus time. On y-axis you have taken velocity, on x-axis it is time. So OA, as it seems from the figure, so we have started our motion from point A. O is the origin, so OA here is the initial velocity. OA from the figure you can see is equal to CD. OA is equal to CD and that is equal to U. That's your initial velocity. Then after starting from A, you reach to point B here. Then at B, V is the final velocity. So BC, which is equal to OE, is your final velocity. So BC is equal to OE is your final velocity V. Then what is OC or what is AD? OC, which is equal to AD, that is the time interval during which this motion is taking place. Okay, so to derive the first equation, that is the velocity time relation, which is v is equal to ut, what will you do? You want to find out that relation, then you need acceleration also in that equation. So you can simply take the slope of this graph, and you have learned that the slope of velocity time graph, it gives you acceleration. Okay, what does it give you? The slope of velocity versus time graph gives acceleration. So we can say that acceleration is equal to slope, which is equal to tan theta, or you simply can say it's the gradient, right? So A is equal to tan theta. So that is your acceleration, and from the figure you can clearly see tan theta is equal to opposite side BD divided by adjacent side AD. So to find BD, what will you do? You will subtract this DC from this whole BC from here. So if you do this BC minus DC, you will have ultimately your BD, and that is equal to V minus U. Why? Because what was DC? You have seen it from here. It is your initial velocity U, and BC was final velocity V. So that will be V minus U divided by T. Take this T on another side with A, the equation becomes V minus U is equal to AT. Take U on other side and you will end up having your equation V is equal to U plus AT. That's it. That is your first equation of velocity time relation. The only thing you need to remember that you took the slope of velocity versus time graph, because the slope of velocity versus time graph gives you the acceleration. Got it? Okay. The next equation. Now we will derive the second equation, that is position time relation. On one side it is s, that is the position, that is the variable. On other side it is t, which is the only variable, because u and a here are constants. Okay, so that's why this relation is known as the position time relationship. So if you want to find out the distance, that is the position of an object or distance traveled by the object, then you will have to go for the area under velocity time graph. So this is your graph OA. So if you want to find out the area, then the only thing you need to do is quite easy stuff which you have learned in mathematics as well, that is a trapezium. So you find out the area of this trapezium OABC. Write down the area of this OABC. So what is the area of that trapezium? Well, it is made up of two parts. One is this triangle, another one is this rectangle. Okay, so to derive that area under position time graph, that is the distance traveled by the object, you first find out the area of the rectangle, and that is equal to OA into OC, and the area of the triangle half of base into height. So if you substitute the values, OA, what is OA? That's your initial velocity u. OC is the time taken, so it is u into t plus half of base. What is the base of this triangle? ADB. AD is the base and height is BD, and we have seen in the first case this BD here is equal to V minus U. So you have substitute BD. AD is your time interval T, because AD is equal to OC. So AD is equal to your time interval. So instead of this V minus U from the first equation of motion, that is velocity time relation. Why do you call it velocity time relation? Because on one side it is V, which is variable, and here T is the variable. U and A are constants. So the equation has only two variables. On one side it's V, other side it's T. That's why it is known as the velocity time equation. So from this equation you get V minus U is equal to AT. That put V minus U is equal to AT in this equation, and you will have this equation S is equal to UT plus half AT square, and that equation is your position time relationship. Is that clear? Very good. Now let's derive the third equation of motion, that is velocity and position relation. On one side it is V, that's why it's velocity. On other side it is S, and that's why it's position. So it's a position time relationship. Rest parameters are constant in this equation. So we'll use the same case, same formula or same method that we did in second case. You will find out the distance traveled by the object, and that is still the area of the trapezium OABC. But in the second case we went for the rectangle plus triangle. Here we will stick to the trapezium and find out the area of the trapezium. You know what is the area of trapezium, right? So area of trapezium is equal to half of sum of parallel sides into the height. So the two parallel sides here are OA and BC. So this parallel side are OA plus BC into OC is your height, and that's your OC, and this is your time interval. So OC is replaced by T, OA is replaced by U, and BC is replaced by V. Again we'll use the first equation, and from first equation you can say that T is equal to V minus U by A. Because V is equal to U plus AT, make T the subject, you may end up having V minus U by A. Substitute the value of T in this equation. So you will have V minus U by A, and here it was U plus V by 2. So keep this 2A together, and this is, you will use the formula A minus B, A plus B. So it's A square minus B square. So with that formula you have V square minus U square. So S is equal to V square minus U square by 2A. Take this 2A on another side with S, so it becomes V square minus U square is equal to 2AS, and that's it. You have your third equation of motion for uniform acceleration. Got it? You don't always have to draw this graph. Draw the graph once only, and from that you can derive all the three equations. You don't need to keep on drawing the diagram for every relationship. Got it? Good. Okay, we will now talk about uniform circular motion. It's a very special kind of motion. Why special? Because this is the motion during which the speed of an object remains constant, but still it is an accelerated motion. Yes, I said accelerated motion. It is a uniform circular motion, but it is still an accelerated motion. How so? Well, let's go for it. So you can consider that you have tied a stone with a thread and you are whirling it. Okay, if you have tied a stone with a thread, you have the thread one end in your hand, and when you are revolving it that way, or when you are rotating it, and when you release it at certain point, then at that particular point, for example, you release it here, then it will go along the direction of the tangent at that particular point. If you do it here, then this tangent. If you do it here or at other point, then at those particular points the stone may move in the direction of the tangent. So the velocity at every point is along the direction of the tangent at that particular point. So circle is made up of infinite points here. So there is infinite change in direction. Infinite change in direction, that means infinite change in velocity. And if velocity changes, then the motion will be the accelerated motion. So though this is the motion with a constant speed, this motion is an accelerated motion. The acceleration which comes into picture here is directed towards the center, and this acceleration is known as the centripetal acceleration. What do we call it? Centripetal acceleration. By centripetal we means towards the center. The direction of the acceleration is towards the center. So motion of all the planets around the sun is in elliptical orbit is one of the example of this kind of motion. Elliptical is almost like this shape which I have drawn around this acceleration. It is not a circle, it is like egg shape. Okay, it's almost egg shape. So those motions are the uniform circular motion, because all the planets have speed constant but direction changes at every instant during their motion. For example, if we talk about our Earth takes 365.25 days to complete a year around the sun. 0.25 into 4 becomes 4, and that is, sorry, becomes 1, and we have a leap year at the interval of every 4 years, right? So this kind of motion in which speed remains constant but direction changes at every point, and every point the direction of the motion is along the direction of the tangent. Okay, so that's your uniform circular motion. So in uniform circular motion, if when the object is here, then you can see I have shown a force towards the center which is responsible for holding all these planets also in its orbit, and the force which holds the planet in their circular orbit towards the sun is known as the centripetal force. Which force is it? It is the centripetal force. So that centripetal force is holding all those mightiest of the planet in those orbits, right? So that force is providing you necessary gravitational force, because if there is no gravitational force between the planets and the sun, then the planet may move along the direction of the tangent, and they ultimately will keep on receding away. Receding away, that means they will keep on going away from the sun, and ultimately they will lose their path, the circular or elliptical path. Okay, so the centripetal force, that is the force towards the center, the force towards the at the same time, there is another force acting on the object, that is the centrifugal force. So centrifugal force is always equal in magnitude to the centripetal force, and it doesn't have its own identity. It doesn't exist on its own. It exists only when centripetal force is present. Learn it here about centripetal and centrifugal force. So centripetal force we have denoted it by FCP here. This is the force acting towards the center, and that's the real force. It actually exists, and it depends on the mass of the planet, the speed with which it is rotating in elliptical or circular orbit, and the radius of the path it is making around the sun. So that's why you have this equation of the centripetal force, that is F is equal to mv square by r, right? Now F centripetal, here we have considered an object at the center. You can understand your sun. So sun, let's take our earth only. So here is our green earth. So on earth there are two forces acting. One is centripetal, another one is the centrifugal. So centripetal force is responsible for holding the holding the earth around the sun. The moment centripetal force raises its hand, sorry dude, no gravity from today. If there is no gravity, there will not be any centripetal force, and we will move out of this path at this point and will start going away along the direction of the tangent. And if there is no sun, there won't be any sustainability of life. There are no chances of survival of life, right? So this force, the gravitational force that we'll study later on, which is the weakest force in nature, though it is the weakest force, it is responsible for holding the mightiest of the object around the sun, and it has made our life possible. Got it? So that is because of the centripetal force. Now Newton's third law states that forces always occur in pair. The two forces occurring are always equal in magnitude and opposite in direction. ठीक है? So forces always are in pairs. Singular force never exists. Simple. There cannot be a single force. There is always another force contradicting to that. So here also we have a centripetal force towards the center. Then at the same instant we might have centrifugal force as well, and it is here shown with the negative sign. That means centrifugal force is acting away from the center. Centrifugal force, here it is a non-real force, it is a fictitious force, right? It's not a real, it's pseudo, it's non-real, it's false, and it's dependent force. Why have I used the word dependent? Because it doesn't have its own identity, it doesn't exist on its own, it exists only when the centripetal force is present. So whenever centripetal force, there will be the centrifugal force equal in magnitude and opposite in direction. Is that clear? And what is the magnitude? Magnitude here is equal to mv square by r. Got it? So centrifugal force is existing only when centripetal force exists, and it acts away, and that is not the real force. Got it? Good. So if when you are driving your car along the curved path, and if you do not get, for example, here this is a curved road this way, okay, so we have to take turn towards this side. On this side it's a deep valley, and if you drive at a certain speed, let's say on a curved road, they already generally mention that this is the maximum speed you should travel on this road to avoid the accidents, not accidents with the vehicle coming from the other end, but you may not sometimes get this necessary centripetal force also, which will keep you towards the center of that road. कि पूरा सर्कल जो रोड का हो सकता था, then on that road only you should stay, and you need to have that necessary centripetal force, you need to have that necessary gravitational force, and you will have it only when you drive it at certain speed. If you drive beyond a certain speed, because of inertia, you may move little straight and may ultimately fall into the valley, and the accidents may happen, right? So that's why they mention there. And the tires of the cars must also be good to have good gravitation, to have good centripetal force. Got it? Okay, then you could say that so centripetal force does not depend upon that quality of the tire, it depends upon M, V and R. That's true, it depends only on those factors, but if the quality of the tire is bad, then also your car may skid, and you may not be able to negotiate this circle, and you will be thrown off the road, and centrifugal force may take you away from that road, and you may fall into valley as well. Is that clear? So here we have learnt about two forces, centripetal and centrifugal force. Centrifugal is a non-real pseudo force. See, I'll give you one more example. For example, here is a train compartment, and you are traveling in that, and you know there are the hangers are suspended there, which we hold it with our hand because sometimes you don't get sit and you have to travel standing. So if the train starts going in this direction, so force is applied in this direction and the train is going. So force is in this direction, train is going in that direction, but this hanger, it is pushed in the backward direction like this. It goes there. So force is here, but the hanger goes towards this side. So why has it gone to that side? Has any kind of force applied on that? No, but still it's going. So the force which comes into picture, which makes this hanger move in the opposite direction, is the centrifugal force. It is a pseudo PSEUDO, that's a non-real force. Is that clear? Good. So in uniform circular motion, speed remains constant, direction changes at every instant. Therefore, the motion is accelerated motion. The acceleration is known as the centripetal acceleration, always directed towards the center. At every point, the acceleration is towards the center. Right? Good. The forces occurring are centripetal and centrifugal force. We are not violating Newton's third law that the forces are occurring in pairs. Okay, good. These three equations of motion, that is V is equal to U plus AT, S is equal to UT plus half AT square, and V square minus U square is equal to 2AS. These three equations takes different form according to the different kind of motion. For example, when the object is thrown upward with some initial non-zero velocity, because when you are throwing up, you obviously cannot have initial velocity 0. So that is some initial non-zero velocity. When you throw the object from this point to a certain height h, then at this point the final velocity v may become 0 because it will have to stop there and then ultimately it starts falling down, right? So v is equal to 0 at highest point and s is replaced by h, that is the height, which is also equal to your distance. So these three equations takes different form from different kind of motion. The first motion when the object is thrown up with some initial velocity. And in this case, while the object is going up, its speed is decreasing. If speed decreasing, that motion is a retarded motion. It's negative accelerated motion. It is negatively accelerated. So acceleration is replaced by minus g. G here is the acceleration due to gravity and it is still the acceleration. So if you write or replace a by g, it doesn't change anything, right? So the first equation becomes v is equal to u minus gt. A is replaced by minus g. At highest point, you can put this v is equal to 0 and you might have this equation u is equal to gt. Got it? Good. Then your next equation s is equal to ut plus half at square. Then again this a is replaced by minus g. This equation becomes ut minus half gt square, right? And the third equation v square minus u square is equal to 2as. At highest point you have kept v here is equal to 0. So you will have minus u square minus 2gh. A is equal to minus g and the equation becomes u square is equal to 2gh. So you can use this equation to derive or to find out the maximum height achieved by the object, right? Now these equations for the motion when the object is falling under the action of gravity alone. So when the object is released from a certain height, it is falling only under the action of gravity. There is no other force acting on it, right? And when you had this object in your hand, so your initial velocity is equal to 0. And acceleration is equal to plus g here because while it is falling down, the speed increases. The speed of an object increases by 9.8 meter per second per second. So 9.8 meter per second by second becomes 9.8 meter per second square. And that is the value of g, 9.8 meter per second square. That is the acceleration due to gravity. Now since this speed is increasing, the motion is speeding up and the acceleration is positive. That's why we are replacing a by positive g. And the v, after falling on the foot, it will definitely be 0, right? When it's fall on the floor, on the earth, it will be 0, but before that the velocity, final velocity, was not equal to 0. And h is equal to s, that is the height. So s is replaced by the height of the object. First equation takes the form v is equal to 0 plus gt. You have kept initial velocity u here is equal to 0. Next equation, h is equal to ut plus half at squared. You can replace this u by 0 here as well. So h is equal to half gt square. And last equation is v square minus u square is equal to 2gh. So u is 0. We have the equation v is equal to under root 2gh. So these are the three equations of motion when the object is thrown up with some initial non-zero velocity, or when the object is falling down under the action of the gravitational force of the earth alone, or under the action of the gravity alone, right? Where this g we have used in this chapter before learning that chapter gravitation is known as the acceleration due to gravity, and it is acting towards the earth, then it is minus 9.8 meter per second square. Is that clear? Good. So the chapter theoretically ends here. We will now do plenty of numericals and we'll understand how these equations play their role and how do actually things happen, right? Good. Thank you. Keep revising, keep studying. Good. Bye bye.